Bismillahirrahmanirrahim. So as you can see, I have written today's topic on the board. Today we are going to discuss about these three: fusion, vaporization, and condensation. Okay. Now fusion, I already introduced you to this topic, right? Fusion, latent heat of fusion. We have already used the value latent heat of fusion for ice in case of solving some numerical problem, right? Okay. So what is fusion? Turning solid to liquid. Okay, if you go through the PDF that I have given you, you will find it there: to transform a substance from solid to liquid by applying heat. Okay, turning a solid into liquid by applying some heat. This process is known as fusion process. Okay, the definite temperature at which a solid starts to melt is its melting point. Like for ice, we know that the melting point of ice is 0 degrees Celsius. Whenever the temperature of ice reaches 0 degrees Celsius, it starts to melt. Okay. This temperature remains unchanged until all the substance melts. This is what we know, right? Until all the ice is converted into water, this temperature will not rise even though you continue to supply the heat. Okay, that is the state change. Okay, and the heat supply during this time we call it latent heat of fusion, if you remember. Okay, then let us take a look at vaporization. Vaporization means from liquid to vapor. Okay, if you convert this liquid to vapor, then this is called vaporization. Now this vaporization actually are of two type. The two type are, one is known as evaporation, another one is called boiling. Now we will try to know what are the difference between them. Okay, if you take a glass of water, or in a pot, let us say you have taken some water and kept it somewhere. Okay, you come back after 1 or 2 days, you will see that the level of water has decreased. There is not the same amount of water that you left it. Okay, so what does it tell you? Some of the water have gone somewhere, but you did not take any water out of the pot. Then where did the water go? The decreased amount of water has been actually converted into water vapor. But how it converted into water vapor? We know that if I want to convert water into water vapor, I need to supply some heat, right? Actually, there has been some heat supply, and using that heat, the water from the surface, you will always remember, if this is our pot, okay, and this is our water, from the surface, the water molecule will be converting into water vapor. Okay, the top surface water will be converted to water vapor. You come after 1 or 2 weeks, you will see that there is no water left in the pot. All the water has been converted into water vapor, even though you did not supply any heat. Okay, so whenever you are not supplying any heat, but still the water is converted into vapor, then that is called evaporation. You don't supply any heat, but still water converts to vapor, that is evaporation. You can do it yourself. Take a glass of water, keep it somewhere for 1 or 2 days. Okay, keep it in a place where nobody can disturb it. Okay, so watch it after 2 3 days, and when you keep it, mark the level that this is the level. Then after 1 or 2 days, check it whether the water level is same at that point or not. Okay, you will see that the water level has decreased. That means the amount of water have decreased. Okay, so some water has been converted into water vapor, even though you did not heat it, or by keeping it on a oven, on a stove or something. Okay, so this is evaporation, that happens automatically. And the other process is boiling, where you supply the heat. You keep a certain amount of water on the stove and you heat it up. Then what will happen? The water temperature will reach to 100 degrees Celsius, and when it reaches 100 degrees Celsius, we know that this is the boiling point of water. So at 100 degrees Celsius, the water will start boiling, and the water will start convert into water vapor. Okay, and until all the water is converted to water vapor, the temperature will not change, right? This is the boiling point, and the heat supplied during this state change, we know that that is called latent heat of vaporization, right? Okay. So these are the two processes of vaporization. The phenomenon of transformation of a liquid from its liquid state to gaseous state is called vaporization. Vaporization may occur in two processes, evaporation and boiling. Evaporation, the process in which a liquid at any temperature, whatever the temperature of the room might be, okay, slowly changes its free surface into vapor. Free surface means the top surface. Okay, this is the free surface. From here, the water will be converted into water vapor, and this is called evaporation. Here they have given some activity, what I already told you. Take some water in a bowl and keep it in a corner of your room. Observe what happens to the water after 1 or 2 days. It will be observed that the water has been reduced. What is the cause for this reduction of water? The water has been converted into vapor, even the room temperature, and for this the amount of water has been lessened. This is called evaporation. Okay. So without supplying any heat, what happens? The water is converted into water vapor. Boiling, the process in which the liquid is rapidly converted. This is a major difference between evaporation and boiling. Okay, many times in the question you will be asked to write the difference between the evaporation and boiling. So that time you have to mention it. Evaporation is a much slower process and boiling is a rapid process, because here we give the heat, we put the water on some stove and the temperature rapidly rises to 100 degrees Celsius, and then the water starts converting into water vapor. Acha. The temperature at which boiling of liquid begins is called the boiling point, which I already told you, which is 100 degrees Celsius. Okay. Acha, the value of this boiling point depends on pressure. This is very important MCQ. Okay, the boiling point, at what temperature the water will start boiling, it depends on the pressure. If you are on the ground, then we know the atmospheric pressure. This is the atmospheric pressure, and at this temperature, we know that the water will start boiling. But let us say you have climbed to a certain height. Okay, you went up to the Mount Everest. Okay, there what will happen, the pressure decreases as you go up from the ground. Okay, the pressure drops. So as the pressure drops, the boiling point also drops. The boiling point will decrease. And I heard that on Mount Everest, the water starts boiling at 70 degrees Celsius. So you see, so you don't have to go up to 100 degrees Celsius. The boiling point has decreased due to the fall of pressure. So as a result, whenever you heat the water over there, it boils very fast, and it converts into water vapor. Now this causes a certain type of problem that I'm going to share with you. Okay, this is also important for 2 marks question. That the question is why it is difficult to cook on Mount Everest, or let us say any mountain. Okay, why it is difficult to cook on the mountain compared to cooking on the ground level. Okay, why it is difficult? Now you see, in whenever we are cooking on the ground level, what is happening? Uh, the boiling point is 100 degrees Celsius, and to reach 100 degrees Celsius you have to supply a certain amount of heat, and that amount of heat is enough to cook the rice. Okay, we know that the rice, to cook the rice properly, so that it does not remain hard or it does not become very soft, we have to supply a certain amount of heat, right? So that certain amount of heat we can supply properly over here to reach the 100 degrees Celsius. But in mountain, what will happen, as the but the boiling point has come down, what will happen? You pour some water, okay, and start cooking the start cooking the rice. Then what will happen? You heat the water, and you will see that very soon the water is gone. Very soon the water has it's vaporized. Okay, so you could not actually supply the required amount of heat to cook the rice yet, and the water is gone, so you have to add more water. So that water will also be gone soon, then you have to add more water. So you see what is the problem. To cook the rice we need a certain amount of heat, before you can supply that amount of heat, if the water is evaporated or the water is has been converted into water vapor, then it is difficult for us to cook, right? So that is why it is difficult to cook on the mountain. Acha. So what is the solution to that? This is also another question. The solution to that is pressure cooker. Okay, we can cook using the pressure cooker anywhere in the world. It doesn't matter. The outside pressure actually does not affect the pressure that is inside the pressure cooker. That is why actually it is known as pressure cooker, because it maintains a certain amount of pressure inside the cooker, and as a result, what happens? The pressure doesn't drop down. Okay, the pressure actually doesn't drop down inside the pressure cooker, so the as the pressure is maintained, the boiling point does not come down. Okay, the boiling point stays at 100 degrees Celsius, which allows us to provide the required amount of heat to cook the rice. Okay, so this is very important. Acha. Then our next topic here, I can see effect of pressure on boiling point. Now this is a topic that I'm willing to discuss in the next class, inshallah. Somebody wrote to me something. Sir, what happens to water when it reaches 100 degree? Okay, Arafat has asked what happens to water when it reaches 100 degree. So the water will start converting into water vapor. That means the water will start boiling. Okay, you see that some bubbles are formed. Okay, and what happens? The water starts to convert into water vapor. If you continue to give up the heat, then what will happen? All the water that you have will be converted to water vapor, and in the pot, no water will be left. Okay. So this is what happens at 100 degrees Celsius. Achha. Then I was saying that effect of pressure on boiling point. This one I'm willing to discuss with you with a video. Actually, there is an interesting experiment that through which we can actually study this topic, effect of pressure on boiling point. Inshallah, we will do that next class. That means that is tomorrow, inshallah. So today, let us finish another topic, that is dependence of evaporation on various factors. Okay, we already got to know what evaporation is, right? Okay, vaporization is converting liquid to vapor, and this has two process, evaporation and boiling. So evaporation, it depends on a couple of factors. What are those factors? Let us see. Okay, dependence of evaporation. Number one, flow of air. Flow of air. Now this one I best understand using the example of wet clothes. Whenever we wash clothes and we put it into the on the roof probably, okay, or wherever the sunlight can reach, we put the clothes over there, right? We expose it to sunlight and we wait for it to get dry. Now sometimes you will see that it is taking less amount of time to get dry, and sometimes it is taking more amount of time. Actually, what is happening? We want the water that is in the cloth to get evaporated, right? If the water that is in the cloth is evaporated, then the cloth will be dry, right? So you see that we are not actually heating the cloth, keeping on a stove, right? We are not heating it. So we are not, this is not actually the boiling. This is evaporating, okay? Without supplying any kind of heat. I'm not supplying any kind of heat, but it's still the water from the cloth is getting evaporated. It's converting into water vapor. So this process is evaporation. Now, sometimes it will be faster, sometimes it will be slower. Now, it is clear that it is depending on couple of factors. That factor, decides whether it will be fast or slow. Now, flow of air, what will be, if the flow of air is more, let us say, you will see that whenever you put the cloth on the roof and there is very good flow of air, okay, the cloth will be dried faster. Okay, so flow of air is one factor of evaporation. If the flow of air is there, then what will happen? The more the flow of air, the more fast will be the drying process. Okay, now why this happens? Because you see, each amount of air has a certain amount of capability of taking the water vapor. Now let us say there is no air flow, so the air that is around the cloth will be taking the water vapor from it, and one time it will become saturated. What do we mean by saturated? Let us say it is like, eating some food. I'm eating some food, still I can eat. I'm not saturated yet. I'm eating some food. I'm not saturated yet. But once upon a time, the time will come when I will feel that I cannot eat anymore. So that time I'm saturated. I cannot take any more food. So for a year, the water vapor is like food. It is taking water vapor. Still, it has some capability to take more water vapor, so it will continue taking. But at some point, it will happen that it is full. The air is full with water vapor. Then no water vapor will be able to enter into the into the air. So as a result, what will happen? The cloth will not be drying anymore. You understand my point? Now, if there is flow of air, then what will happen? Some amount of air will come. It will take some amount of water vapor. It will go as it is flowing. The next batch of air will come. It will take some water vapor and it will go. So if there is continuous flow of air, then what will happen? They will be continuously taking the water vapor, water from the uh, cloth, and they will be going away. So in this process, we understand that if the flow of air is there, then what will happen? The process will be faster. Okay, this is number one. Then number two, the area of exposed surface. Okay, now let us say I have kept a certain amount of water in this glass, okay, up to this level. This is the water level, okay, and then I have kept the same amount of water in another pot, okay. This is the place, and let us say the water is this much now. From where the evaporation will be higher? Can you tell me?
Sir, potato.
Sir,
From
second one.
second one.
Right.
Yeah.
You understand the concept, right? Here, the exposed surface, we know that from the top free surface, the evaporation starts, right? So if this surface is bigger, then what will happen? More amount of water will be evaporated from here, and this will, the water that is in the pot will come to an end faster than the water that is kept in the glass. Okay. So you see, area of exposed surface is another factor of evaporation. If the area is more, exposed area is more or bigger or larger, then we can say that the evaporation will be faster. Okay, so this is another factor. Number three factor, we have the nature of liquid. The nature of liquid. Now we know that liquid to liquid, the rate of evaporation might vary. Okay, you will see that you have 10 gram of water. You will notice that how much time it is taking to evaporate. If you take some other liquid, let us say you took kerosene, okay, the same 10 gram of kerosene, you will see that it is taking different amount of time to evaporate, though all other factors are same for both of them, right? The flow of air same, area of exposed surface same, everything is same, but still due to the change of nature of liquid, you will see that the time varies. Okay, the time taken to evaporate. So that is there. Okay. Then pressure on the liquid. We have already got to know that pressure is a great factor, right? So pressure on the liquid. So if the pressure is more, then what will happen? Can you guess? The rate of evaporation. Remember, this is the inverse relation. Very important for MCQ. If the pressure increases, the evaporation will decrease. Remember, opposite relation, very important for MCQ. If the pressure on the liquid increases, then the evaporation rate will decrease. And if the pressure on the liquid decreases, then evaporation will increase. Always remember. And then we have liquid and the temperature of air in contact with the liquid. Yes.
Sir, you can explain phone number again.
Number 4, pressure.
Yeah.
Pressure on the liquid. If the pressure increases, the evaporation will decrease. Opposite relation. Okay. We know that the pressure varies, right, from place to place. Like on the ground level, there is some atmospheric pressure that we know the value of. Okay, 10 to the power 5 Newton per meter square. But if you go to some mountain, then what will happen? The pressure will change. So on the mountain, the pressure drops. As the pressure drops, you will see that the evaporation is higher. Okay, it will be faster. Higher means fast evaporation of everything. Okay, opposite relation. Robin.
Yes, sir. Okay, sir.
Okay. Acha. So the liquid and the temperature of air in contact with the liquid. Yes. You see that on a hot sunny day or during the summer season, the water gets dry very fast. But during the winter season, that is not the case, right? What is the difference between summer and winter? The temperature.
Yes.
The temperature is the difference, right? In summer, the temperature of air is high. So as a result, what will happen? The evaporation will be higher. And during winter season, the temperature is lower. So the drying process will be delayed a little bit. Acha. So that is number 5, okay? Temperature. I will just write in short, okay? And then dryness of the air. This is another important thing, okay? Number 6, dryness. If the air around the clothes are dry, then what is happening? Dry air is like a hungry person. Okay, I do not have any food inside me, so I can eat more and more. Like that, if the air is dry, that means it has the capability to take more and more water vapor. So as a result, when it takes the water vapor, then the air becomes wet. Before it takes water vapor, it remains dry. So if the air is dry, then what will happen? It will be able to take more water vapor. But if the air is already wet, then what will happen? It will not be able to take much amount of water vapor, right? So the dryness of air is also another factor. If the air around us is, dry, then what will happen? Evaporation will be faster. Dryness of air. Dryness of air. If the dryness of air is more dry, okay, drier air means faster evaporation. Okay. I think we have covered all the topic. Yes. So these 6 are the factors which actually decides whether the evaporation process will be faster or slower. Okay. So kindly keep all of them in your mind, and maybe you will be asked to explain one of them for 2 marks, or might be you'll be asked that write 4 factor of evaporation. So that time you can mention any 4 of them. Okay. Acha. So if you understand it, then you can write it. Okay. Just 1 or 2 line. If you are asked to explain that, explain how area of exposed surface decides whether the evaporation will be higher or lower. Okay. Or the question might be in this way, that explain why area of exposed surface is a factor of evaporation. Then you may explain with a figure like this. You explaining through a figure is much more easier. See, when I drew these 2 figure, you only answered me that sir, from here the evaporation will be more. So you see, through a figure the explanation is better. Sometimes you don't have to even explain
Sir,
or full. Yes.
can you explain number 6 again?
বুঝি নাই কোনটা?
Number 6.
Number 6 is dryness of air. If the air around us is dry, dry means what? It does not have much amount of water vapor in it. What does that mean? It is hungry. That means it can take more amount of water vapor. But if the air around us is already wet, that means it is already almost full with water vapor, it will not be able to take much amount of water vapor. So the clothes will take more time to become dry. Do you understand?
Yes, sir.
Okay. So dryness of is also an important factor. Acha. So with that, Alhamdulillah, we are almost done with the chapter. Only one topic is left, that is effect of pressure on boiling point. Let me give you an idea actually what is this, we will see that if we have two piece of ice in our hand and we press them tightly against each other, you know what will happen? They will become joined and they will become one piece of ice. Okay, this is very interesting. But we have to do this at a temperature that is
Sir, what? You can say again what you say. Two eyes.
দুইটা আইস পিস বরফের টুকরা নিয়ে তুমি যদি একটার সাথে আরেকটা জোরে এভাবে মনে করো এই দুইটা আইস পিস, ঠিক আছে, এই দুইটাকে আমি জোরে মানে চাপ দিয়ে এইভাবে লাগাই রাখলাম, ঠিক আছে। সো কি হবে, কিছুক্ষণ পরে দেখবা যে এরা জোড়া লেগে গেছে, দে আর নট সেপারেট এনিমোর, ওরা জোড়া লেগে গেছে, একটা আইস পিস হয়ে গেছে। তো এটা কেন হয় সেটাই আমরা পরের দিন শিখবো ইনশাআল্লাহ। ওকে
স্যার এটাতে সল্ট দিলে তো হয় না? সল্ট
না, সল্টের বিষয়টা আমি জানি না, আমি যেটা জানি আসলে সেটা হচ্ছে ওই যে প্রেসারের কারণে, যখন তুমি প্রেসার দিবা এদের মেল্টিং পয়েন্টটা ডাউন হয়ে যায়। মেল্টিং পয়েন্টটা যখন কমে যাবে তখনই সাথে সাথে কি হবে, এই মাঝখানে কিছু পরিমাণ আইস ওয়াটারে কনভার্ট হবে। তো তারপরে তুমি যখন প্রেসারটা একটু রিলিজ করবা সেই ওয়াটারটাই আবার আইসে কনভার্ট হয়ে এই দুইটাকে কি করবে, ওই ব্রিজের মতো করে কানেক্ট করে দিবে। এটা আমি মুখে বললে হয়তোবা তোমরা এত ভালো বুঝবা না, সে কারণে আমি বলতেছি যে একটা এক্সপেরিমেন্ট বা একটা অ্যানিমেশন ভিডিও থ্রুতে আমি পরের ক্লাসে ইনশাআল্লাহ এক্সপ্লেইন করার চেষ্টা করব, তখন এটা তোমাদের কাছে আরো ইজি মনে হবে ইনশাআল্লাহ। ওকে, আচ্ছা, লাস্ট ভালো কথা মনে পড়ছে। ওকে, a very important question for 2 mark. Okay, that is they will ask you evaporation produces cooling, explain it. The question is, একটা কথা আছে যে evaporation produces cooling, explain. So we can actually explain this topic using two examples. Number one is, let us say you played some games and you sweated, or you did some work through which you actually sweated a lot. Your full body is, now full of sweat. Okay. Now, what happens when you sit in front of a fan? What actually happens? The flow of air is there, right? কেন আমরা ফ্যানের সামনে বসি? ফ্যানের সামনে বসলেই যেটা হয় কি, ফ্লো অফ এয়ার হয়, এন্ড ফ্লো অফ এয়ার হওয়ার কারণে আমাদের বডি থেকে সোয়েটটা কি হয়, তাড়াতাড়ি ইভাপোরেট হয়ে যায়। আমরা একটু আগে পড়ছি যে ফ্লো অফ এয়ার যত বেশি থাকবে তত তাড়াতাড়ি ওয়াটার ইভাপোরেট হবে। সোয়েট ইজ ওয়াটার, সো ওয়াটার তাড়াতাড়ি ইভাপোরেট হয়। তুমি যদি ফ্যানের সামনে ছাড়া অন্য যে কোনো কোথাও বসে থাকো, দেখবে যে তোমার ঘামটা শুকাইতে একটু বেশি সময় লাগতেছে। তো যখন ঘামটা শুকাই যাবে তুমি দেখবা যে তোমার বডি ঠান্ডা হয়ে গেছে। ইভাপোরেশন প্রোডিউসেস কুলিং। কেন এই বডিটা তোমার ঠান্ডা হয়ে গেল? একটা জিনিস খেয়াল করো, আমরা জানি যখনই ওয়াটার ইভাপোরেট হয় তার কিছু অ্যামাউন্ট অফ হিট দরকার হয়। এখন তোমার বডিতে যে সোয়েটটা ছিল সেটা যে ইভাপোরেট হইলো, এটার জন্য তো তুমি কোনো হিট সাপ্লাই দাও নাই। তুমি কি এটাকে ওভেনের উপরে হিট করছো বা নিজে ওভেনে ঢুকে গিয়ে হিট করছো নিজেকে? You didn't do anything like that, but still it evaporated. That means it got the heat required to evaporate from somewhere else. That from somewhere else is actually your body. তোমার বডি থেকে ও হিট নিয়ে ইভাপোরেট হয়ে গেছে। বুঝতে পারতেছো? সোয়েট কি করবে, তোমার বডি থেকে যে ওর ইভাপোরেট হওয়ার জন্য যে হিটটা লাগবে সেটা তোমার বডি থেকে নিয়ে ও ইভাপোরেট হয়ে যাবে। তোমার বডি যেহেতু হিট লুজ করতেছে, দেখো তোমার বডি হিট লুজ করতেছে আর সোয়েট ও হিট গেইন করতেছে। তোমার বডি যেহেতু হিট লুজ করতেছে, তোমার বডির টেম্পারেচার তখন ডাউন হয়ে যাবে। টেম্পারেচার ডাউন হয়ে যাওয়া মানে কুলিং। সি দা মানে আল্লাহ কত নাইস প্রসেস দিয়ে রাখছে দুনিয়াতে। দেখো তো, সোয়েটও ইভাপোরেট হয়ে গেল, তোমার বডিটাও ঠান্ডা হয়ে গেল। ঠিক আছে, কত নাইস একটা প্রসেস। সো এটা একটা মানে এক্সাম্পল যেটা দিয়ে আমরা এক্সপ্লেইন করতে পারি দ্যাট ইভাপোরেশন প্রোডিউসেস কুলিং। আবার আরেকটা প্রসেস আছে যেটা মানে গ্রামে যারা কলসির ভিতরে পানি রাখে না, তাদের দেখবে কলসির ভিতরে পানিগুলা প্রথমে রাখার সময় যতটুকু ঠান্ডা ছিল পরে আরো বেশি ঠান্ডা হয়ে যায়। কেন, কিভাবে ঠান্ডা হয়? এখন কলসির মধ্যে ছোট ছোট ফুটা থাকে, তাই না? তুমি সব যদি ভালো মতো একদম জুম করে দেখো আসলে, তাহলে দেখবা কলসির মধ্যে ছোট ছোট ফুটা থাকে। এই ফুটাগুলা দিয়ে ওয়াটার ইভাপোরেট হইতে থাকে। এখন এই যে ওয়াটার যেগুলো ইভাপোরেট হয় সেগুলো হিটটা কোথা থেকে পায়? কলসির ভিতরে যে ওয়াটারটা আছে না, সেখান থেকে ওরা কি করে, হিটটা নিয়ে বাইরে মানে সারফেসের সাথে লাগানো যে ওয়াটারগুলো আছে সেগুলো ইভাপোরেট হয়ে যায়। এখন কলসির ভিতরের ওয়াটারগুলো থেকে যেহেতু কন্টিনিউয়াসলি ও হিট নিয়ে ইভাপোরেট হয়ে যাচ্ছে, কলসির ভিতরের পানিগুলো এখন কুল হয়ে যায়। কি বলছে বুঝতে পারছো? যেগুলা মাটির কলসি, তোমরা আবার টিনের কলসি মনে করবা, নো টিনের কলসি না, সেটা হচ্ছে মাটির কলসি যেগুলা, এগুলাতে ওই যে ছোট 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 ফুটা থাকে, এই ফুটাগুলো দিয়ে ওয়াটার বের হয়ে ইভাপোরেট হইতে থাকে। তো এখন এই যে ওয়াটারগুলো ইভাপোরেট হবে সেটার জন্য রিকোয়ার্ড অ্যামাউন্ট অফ হিট ও কলসির ভিতরে যে ওয়াটারগুলো আছে সেগুলা থেকে নিয়ে নেয়। সো কলসির ভিতরের ওয়াটারগুলো হিট দিতে থাকে এবং নিজেরা কুল হইতে থাকে। সো দিস ইজ অ্যানাদার এক্সাম্পল অফ ইভাপোরেশন প্রোডিউসেস কুলিং। ঠিক আছে? তো এই একটা কোশ্চেন দিয়ে আমি তিনটা কোশ্চেনের আনসার তোমাদেরকে শিখিয়ে ফেলছি। সেটা হচ্ছে যদি আসে এই কোশ্চেনটা, evaporation produces cooling, explain, you can explain it using one of the two examples that I just discussed. Then again, sometimes they will ask you that when the sweat evaporates your body gets cooled, why? এটার আনসারও তোমরা শিখে গেছো। দেন আবার এটাও জিজ্ঞেস করতে পারে that in villages, okay, whenever the water is kept in the pitcher, okay, after some time the water inside the pitcher becomes cool, why? Explain. So এই তিনটার আনসার তোমরা এখন জেনে গেছো, very important for 2 marks. Okay, understood?
Yes, sir.
Okay, great. So that actually brings us to the end of the chapter. Only one topic left. Inshallah, tomorrow we will discuss it, and after that I will be giving you some creative to solve those creatives, and we will be done with this chapter. Okay, alhamdulillah. So see you in the next class. Before I end the class, anybody wants to ask any questions?
No, sir.
Okay.